So let's start. Yes, screen visible. Okay. Hello everyone. Uh, my name is Tushar. I'm from WebOps and Blockchain Club here at IIT Madras. Today I'll be taking the session into what is blockchain technology. So let's get started right away. And these will be the topics we'll be discussing today. We'll, I'll give an introduction to blockchain and its fundamental concepts. What are wallets? What are smart contracts? And some basics of coding in Solidity and understanding the potential application of blockchain. So before we move on to before we move on to actually what is a blockchain, I think I should give some kind of context before we get into the main concepts. As you know, in this day and age, everything is centralized. Centralized means the power is saturated only at the top of any company, and which leads to several negative effects, especially in the finance sector. Centralized system often result in higher transaction fees and slower processing times due to relying on these middlemen such as banks and processes. These middlemen also introduce a single point of failure, making them vulnerable to hacks, outages, and operational inefficiencies. And this centralized control can lead to censorship and limited access as authorities have access authorities have power to block and restrict transactions based on any arbitrary criteria. And they often lack transparency, making it very difficult to trust these middlemen that they are managing the funds ethically and securely. And everything happens here behind the closed doors. You don't know what is going on. And due to this lack of transparency, many scams and bank making shady deals happen, which happened in 2008. Uh, Banks took bad bets, which brought economy to its knees. The, as you know, the famous economic crisis in 2008. So, looking at this, few smart people, I don't know if it is a single person or a group, a few smart people in 2008 or 9 came together to create this technology called blockchain, such that the system is transparent and decentralized. Basically, what they want to do is create a peer-to-peer transaction system where you effectively eliminate these middlemen called banks. There would be no need for banks. Remember, this is the early days of blockchain. So as we move further and further, we'll see how this technology evolved beyond finance. So let's get started. So what is a blockchain? It's a clever system of decentralized, immutable, and trustless verification based on some of the math born in cryptography. What does decentralized mean? Decentralized means the distribution of power. What does immutability mean? Immutable means you cannot change anything in that. And it is based on cryptography. I'm sure many of you know what is cryptography. Cryptography is a field in mathematics where you change some data into a difficult to decode message, which is difficult to decode. And how it works? It works by creating blocks of data that are linked together in a chain-like structure, and each block contains a set of transactions or data. This is a simple physical representation for blockchain. I know this is pretty vague, so we'll learn about it in a visual manner. There's a website where you can learn how we'll go about this. So before we know how it works, we'll see what are the basic components of a blockchain are. You need to know these basic components, and you will get to know why these one contribute, why what does this one do and other one does to help this technology more secure and desirable. So we'll see what are the components. We'll see first what a hash is. What is a hash? It is a unique alphanumeric string generated through a specific mathematical algorithm. And each block has a unique hash depending on factors like previous block, the data inside the block, nonce, and we'll see what these are. So we'll see first what this are. This is a SHA-256 hash function. So effectively what it does is to type in any data, it takes this data, passes through a cryptographic hash function called SHA-256, and it generates this hash down here. And since you cannot, and this cryptographic hash function has certain special properties we desire so much, so that we use this in our technology. And the way it changes is completely unpredictable. Even if you add a dot or anything else, it changes very unpredictably. So let's look at what are the properties it has for us. It is just not any hash function. It is a cryptographic hash function, which means it cannot be backtracked. Means I'll give you the hash and you cannot backtrack it to get the data here. Even if I give you the hash, you cannot say, okay, the data is cat, anything. It is very difficult. It is nothing better than guessing it what it would be. You cannot backtrack it. And it is a produces string of same length no matter how big or small the input is. So what do you mean by this? For cat, the length of the hash is this much. Even if I type something other than cat, the string, the hash length doesn't change. It always remains constant, whatever, whether it stays empty or whether you put a story in it, it always returns same length. Length is 256 bits. It doesn't change. It doesn't go beyond or less than value here. It doesn't change the length. And it takes in any value, whether it is a string or number or any other character, it doesn't matter. It just pushes it to the algorithm and gives the hash. No matter how many times you put the same string, it returns the same hash. At the same time, it is not anything random. If you put the same data anywhere, you get the same hash every time. Let's say I put cat now and I'm erasing it. Again, cat. You get the same hash every time. So it is like sort of a fingerprint of the data. What it does is every time the fingerprint doesn't change, right? So the data here gives a sort of digital fingerprint. Hash gives a digital fingerprint of the data what we put in there. And we'll sort of extend this idea to what is known as a block in a blockchain. So what it does now, the data here, I'm splitting it into three parts: block, nonce, and data. You may see that here you can put any data, anything, and the block turns red, which means the block is getting invalidated. Why? Let's see. So if I click mine here, the block again turns green, which means that whenever a block hash starts with 4 zeros, it means the block is valid or signed. This is a condition for a block to be valid in a blockchain context. Uh, Whatever data you put in, you mine this and you get a hash starting with 4 zeros. This is our puzzle generally to get. And the nonce here is also changed, which means that you change the nonce such that you start with 1, 2, 3, 4, and you find the appropriate uh, none such that the hash starts with 40. That's how you sign a block, you mine a block. This process of getting appropriate none such that your hash starts with 4 zeros is called mining. And this puzzle essentially for starting with 4 zeros or 5 zeros differs from blockchain to blockchain, but we'll get into it. And so now you have a block, a blockchain. So how do you sort of chain them together? How? Here you can see the block remains the same. One block number, nuns, data, and we are adding an extra factor called previous blocks hash here. You can see this block where hash takes in here. Here in block context, what it does is it takes block, nuns, and data, takes all three, pushes it to the hash function, gets the hash. Here, additionally, we put in a previous block's hash too, such that they are sort of chained together. Here, you see this block points to this the previous block, and this block points to the previous block. Sort of, these blocks are chained together by adding just a previous hash. As you can see, the block hash starts with 40, and these all blocks are all valid. Hence, this is a blockchain. Let's see if I try to tamper with it someday. Let's say tamper with this block. As you can see, the blocks following the block are all getting invalidated. Why? The hash, what it does, it takes in block, nuns, data, and the previous hash, collects an hash, and it is very unlikely that the block hash start with 4 zeros. So this blocks get invalidated, and this hash, as this block gets invalidated, the hash is getting carried on to the next block. As you can see, this hash and this hash are the same. So this blocks get invalidated. This blocks get invalidated because its hash changes. Its hash doesn't start with 4 zeros, and this block too gets changed. This is how a blockchain does its immutability. A blockchain is considered valid if uh, if all the blocks in a blockchain are said to be valid or signed. How does a block get signed? If its hash starts with 4 zeros. So what should I do to make this blockchain valid again? I just mine them. Mine them. You can see now the blockchain is valid again. Just now I said it is immutability, right? It doesn't make any difference. I just change the tamper the data in it and just mine the blocks, and again I get the blockchain validated. As you can see, the person who's holding the blockchain has the power whether to change it or not. So what do we do with this power? We distribute it to other people who are in the blockchain. What do we do with this? We distributed it to several people so that the power gets distributed, and so that the person who has the blockchain no longer only a single person holds the power to change in the blockchain, but everyone does. So how do you, and this ensures centrality and immutability. How? Let's see a person, peer A, tries to act maliciously and trying to tamper with this some data here. And as you can see, these blocks get invalidated and he mines them. And the blockchain is valid now. So what happens is these blockchain gets compared with the other chains in the other with other person who has the same blockchain. What they do is they check, okay, the hash here is 0001B9, and here it is E4B. Okay, these two will start fighting that, okay, who's the correct block, and these both will go to the other guy, and they see that, okay, the hash here is 000E4B, here is it 00E4B, and here it is 001B9. So by this, we know that these two didn't tamper them. This guy tampered with the block, So essentially, what they do is they kick him out of the network, and and the person uh, they kick him out of the network, and the person who has the what to say the and the person who has the blockchain in his hands, who runs this blockchain, who maintains this blockchain, are called nodes. So and whoever keeps they essentially and these two guys form a network. First, these three were a network in a network of same blockchain, and this guy tampered with it. And in a blockchain, majority rules. So what happens is these both guys match, and essentially they kick this guy out. And this somehow as you can see, the network initial blockchain, what it was, it is still untampered, and still this is how it sort of uh, resists uh, immutability, whether you can change it or not by being decentralized. You distribute this blockchain to other, and the person who has a copy of the blockchain is known as a node. And there are almost, if you take any famous blockchain technology, like so, which any software which uses blockchain technology or Bitcoin, it has about 18,000 nodes, and these guys maintain a copy of each ledger. Each These guys maintain a copy of the blockchain with them, so that the power is distributed among the nodes. And this somehow this is a part of centrality, and you can see that immutability is a consequence of decentrality. Whether if you distribute the blockchain, you can essentially kick out the nodes who are acting maliciously and everything. And remember that in a blockchain, a majority rules. Now you see that this data here doesn't make much sense to us. I'm typing everything here. So we'll see how actually, okay, this is how the data is in here. Essentially, uh, this is how in a blockchain the data is handled. Essentially, the data here is consists of fully of transactions from, let's say, $25 is sent from Darcy to Bingley and everything. This is how. And when you try to change, let's say I'm Rick and I'm Elisa and I'm trying to manipulate that. Okay, Rick sent me $620. I can mine them. I can just mine them and see that. Okay, you can see that if you mine them, this these two see that okay, you're not matching with us, and they effectively kick him out. And this doesn't happen usually, and there's a major flaw too. Just like how uh, there's a and this is how transactions are being sent in a blockchain and everything. And as you can see, this is an existing blockchain. You now know how an existing blockchain cannot be tampered with it. You can't tamper anything. If you try to tamper with it, you can't do anything and everything. Now, as you see, transactions keep happening in the real world, right? This won't be it. The blockchain won't be restricted to just 5 blocks. The blockchain keeps growing. So how do we see that? How do we keep adding new blocks? Essentially, what happens is you go to a website, you request a transaction, and what happens is as soon as the transaction comes, every node hears the transaction, and they try to condense it into a block and mine them with the hash of this block added to it. They mine them and they add it to this blockchain. So, and one of the major problem is how do we know that This is what the intended user tried to send. Let's say how how do we know that okay, Emily is the one who intended this transaction to go uh, from her to Jackson? How do we know that? This is a very good problem actually. This has been a problem in the start of blockchain, and there is another factor which is known as, we'll see, this is where we delve into the concept called as private and public keys. How do in traditional financial system we sign our transactions, right? Like, okay, this is me that I intended to send some money to someone else. We sign the transaction. So here in blockchain, how do we sign transactions? Essentially, what you do is you generate a public and private keys. What it does, this is again generated through a cryptographic algorithm, and what it does is you select any random key. The private key can be anything. You can enter some number. It can be very short, long, anything. The bigger the private key is, the more secure. Uh, as the name suggests, private key is something you keep with yourself, and public key is what you publish to everyone in the ledger, in the blockchain. And let's see how you do signatures with it. What you do is there's a message, something like I sent some amount of money to someone. Let's say that message is denoted by hi something, and with your private key, you sign the transaction first. And how this works? This is another cryptographic algorithm. We need not know what is the algorithm and everything. You just know that okay, this and put together into an cryptographic algorithm. You get this message signature here. You sign them, and once you go to verify, and the nodes in the network who hear your transactions and condense them into a block and add it to the blockchain, what they do is they see your message, they see your public key too, which is why you publish the public key with the message and the signature. Essentially, they can verify your transaction. Okay, this is how you know that okay, this is what the intender has intended to send. Yeah, and anybody can't just take your signature, right? If you put something here, hey, this is the transaction they intended to send, and once the node verifies, you know that okay, this is not what the transaction intended to go through. Uh, this is essentially take care of what a signature is. And now we'll see how an actual transaction takes place in a blockchain. What you do is this is the message I'm sending $20 to from this public address to this public address, and you're signing your message with your private key, and it produces this message signature here. You do is you verify with your signature, and this is your effectively public key or public address, both are the same. What it does, message, this is the public key, signature, and it verifies the signature. Okay, notes verify this, and we'll see how it works in a blockchain context. You see, this is the same thing, same as this step that people send money from this to this previous hash, and additionally, we're adding a signature so that we know that okay, this person intended this $7 to this address by his signature, and this has been verified. Let's see, I'm trying to tamper with this. 70. As you can see, the block becomes unsigned, first of all. Next, if you see, the signature becomes red. That means the signature is not being verified. Even if you mine the block, the signature still remains invalid. By this, you know that okay, someone has been trying to maliciously act, and they just don't consider this transaction at all while mining the block. So this is how in a blockchain everything works. Now we'll go about this is how roughly a blockchain works in a visual manner. Now we'll go through some formalities and learn what are the what are the components essentially by through definitions formally. So what is a nonce? It is a value that is included in a block. In mining, it is an arbitrary value that miners modify within a block in order to meet a certain condition to satisfy a specific cryptographic puzzle. What is it? As you can see, yes, this is what I'm saying. This is the nonce. So this is what the miners are trying to solve and modify within a block to get nonce to satisfy a specific cryptographic puzzle. What is the puzzle? In our demo, it is find a hash that starts with 4 zeros. Find a nonce such that the hash starts with 4 zeros. And briefly, this is what nonce means. What are nodes? Nodes are the computers, refers to the computers that take part in maintaining the integrity of the decentralized network. And the control of the blockchain is distributed among the nodes. Yes, that's what ensures. That's what I said here. The nodes, each of them get a copy of the blockchain. They essentially uh, maintain a copy of the entire blockchain ledger, which contains all transactions and data that have ever occurred on the network. And we'll see what is a little bit of what is cryptocurrency. Actually, here in this demo, you can see here they it is mentioning $97 from this to this to this, but essentially it is not dollars, but some cryptocurrency is being sent. So what is a cryptocurrency? It is a digital or virtual currency that uses cryptography for secure transactions. It operates on a blockchain, and cryptocurrencies enable direct peer-to-peer transactions without the need for intermediaries like banks and allow for fast and more efficient exchanges. Essentially, what they do is this is not dollar actually. This is cryptocurrency. Each blockchain have their own cryptocurrencies, have their own set of uh, dollars which they can send. They don't want any dollars into their blockchain. Uh, they just send what is native to the blockchain, known as cryptocurrency. And every blockchain has their own native currency. Uh, they send it in the blockchain, which is not dollars. There are cryptocurrencies. And we dive into what is known as what are the consensus protocol. Uh, so consensus is a mechanism which is used to agree on a state of blockchain. And this protocol can be roughly divided into two types: chain selection rule and Sybil resistance. What are those? Chain selection is the process of choosing the correct version of a blockchain. One common method is called the longest chain rule, in which all participants look at different versions of blockchain and choose the one that has most blocks in it. Suppose you're joining network, you're seeing for the same purpose 2 to 3 different blockchains. And what would you choose in that situation? You just have to wait for some time, see which blockchain is the longest, which gets uh, it is getting which is getting bigger and bigger. Essentially, you choose that blockchain. Why? This is a little bit in depth. We'll not be discussing why we are going to choose the longest chain here. This is what was the problem that was solved in 2008 and 9. We'll not looking in depth into it. Just you just have to trust that the longest blockchain is the correct version. Basically, what is tells us the truth. What is the truth in a blockchain? Defines what is the truth. That is what it means by used to agree on the state of a blockchain. And This is broken down two types, right? This is the chain selection rule. And second one is Sybil resistance. What is Sybil resistance? Sybil resistance refers to the ability of a blockchain to defend against Sybil attacks. What are Sybil attacks? Sybil attacks occur when one entity creates multiple fake accounts to gain a disproportionately large influence in a network, often to disrupt or manipulate it. As you can see, as I said here, blockchain, majority rules, right? So as you can see here, the two persons check themselves and see, okay, these two match and this is not matching, and they just kick him out. So what happens if this person creates comes as comes as two different nodes? Let's say there are three nodes, and three of them are the same person as this guy, and these two have the same blockchain ledger. This guy has the tampered blockchain with him. So effectively, what would happen? These three guys, but essentially he's a one guy only. He has the tampered blockchain. He has three nodes which have the tampered blockchain, and these two are the whatever good nodes. They have the correct one. Essentially, what he can do is he can do something called as fork. He can fork the blockchain and change the network into his uh, direction. And as you can see, this is a major problem, right? If you can just, this is what a Sybil attack means. What they do is they create many different accounts possessing its nodes, but essentially it is same node to gain advantage and sort of fork the blockchain to manipulate it to his own advantage. And there are some mechanisms we look into it. There are two Sybil resistance mechanism, and what the and Sybil resistance mechanism is the ability to of the network to defend against the Sybil attack, like a node creating multiple different accounts and trying to influence the network. And we'll look into one of these Sybil resistance mechanism, proof of work. And what does this do? Essentially, actually, mining is a very expensive process. Actually, it is not as simple as, hey, I can just manipulate the data here and click mine. In just few seconds, the hash comes out here. But this is not in actual blockchains, in real world blockchains. This is for our demo, starting with 4 zeros. In actual world, in actual blockchain, that puzzle, find the solution to a complex mathematical puzzle is actually very, very difficult. It is very, very expensive. If a person tries to uh, somehow influence the network by creating multiple nodes, he has to go through this expensive, very computationally expensive process, and it is he cannot essentially, and maybe here from just 1 to 3 persons you can do it, maybe here essentially you can create poses three nodes and just fork the network. But what if there are 10 nodes? What if there are 20 nodes, 1,000 nodes, 2,000 nodes? In that case, the computational expensiveness goes astronomical. You can't just compete with the network unless and until you have 51% of the whole computational resources of the whole network. You can't compete with them. And this is what this mechanism describes. Is uh, This is what it describes. Essentially, this mining, what we do here, is a part of proof of work actually, uh, and this somehow secures the network. This is how it secures the network, because he cannot pretend going through multiple accounts, creating multiple accounts, running to find the complex mathematical solutions, and he can't just do that. It is just too high, too much of a computational resources to trying to defend the network. And as I said before, uh, and these guys who find the solution are called miners. So what do? They hear the uh, message request which you send through the blockchain. You hear the request, like, okay, this guy sends this guy this much signed transaction. You even verify it. You hear those signed transactions. Every node in the network hears signed transaction, and what they do is they condense it to a block and start mining them, sort of finding the cryptographic puzzle they have to solve. In actual blockchains, it is, for example, this would be not just 4 zeros, it would be 30 zeros, which is quite difficult to find. You have to spend so much computation resource to find it. And why do miners do this? Why do have they waste their computational resources and everything? Because they receive something called as block reward. And these block reward are what they do is when they get a block, when they hear transactions and set them into a block, they add their own transaction at the top of the block. Like I get some native cryptocurrency of the blockchain, some amount of the native cryptocurrency of the blockchain, and they start mining it. This is an inbuilt. This is this reward is actually so much desirable to the miners. This is actually very expensive. You can check in the internet uh, how much block reward do you get in for mining in a Bitcoin blockchain. You can see that, and you can see how much a Bitcoin costs too. This is actually very desirable. So what they do is every node who hears the broadcasting of signed transaction, they combine the take those transactions, add the reward, and start mining them. When they start mining them, what happens is every node starts mining them. Every node, because they're after this block reward, which is quite desirable. So they start mining them, and every block is sort of a miniature lottery to them. They can't just every every block is sort of a miniature lottery to them, and they desire it very much. So they start mining it. After that, if one of the, let's say a miner gets it and he receives the reward, not just like that. First, the miner publishes the block and other nodes verify it. Once after verifying the block, they add it to their blockchain and the miner gets reward. As you can see, this is actually very, very computationally expensive. Now, every node, I imagine just every node uh, running to solve this puzzle, tough mathematical puzzle, spending so much computational resource. And at the last, at last, only one node gets it, and he publishes, and other nodes just validate it and send it to the block. Every node tries, every node sort of runs to this to get this network, to get this reward. This is very actually very, very environmentally damaging, as every node is trying to do it. So instead of this, people have moved on to another Sybil resistance mechanism known as proof of stake. And what they do is here participants are known as validators, lock up a certain amount of cryptocurrency and tokens as their stake in the network. And one validator is chosen randomly, not actually randomly. The one who has put up more stake into the blockchain, he's chosen. He has the more chances to get chosen. He is, and one of them is chosen. He publishes the block. He sort of validates the block, uh, mines the block, and publishes to the network. And other nodes just validate it. And this, if a validator acts maliciously, he would be siphoned some whatever stake he has put up in the network. He would be ripped off of it, because and the nodes have very high stakes in the network, such that higher the stakes and the more the good behavior the nodes would behave. Otherwise, if a node with higher stakes starts to act maliciously, like tampering with the block, anything like that, once the other nodes verify and see that, okay, this node has been acting maliciously, the stake, the collateral he has put up will be stashed. He will be taken. They will be take. he will be robbed of his uh, stake. And you may ask, how does this defend against a node creating multiple accounts and everything? Because if a person wants to participate in this process, he has to put up a lot of stake. What he does is, in this, he has to put up stake in every node he creates. And once a node starts agreeing with this node, essentially they become partners in crime. So he just, and when a majority of the, let's say a 10 nodes starts acting maliciously against a network of 30 nodes, then they find that this 10 nodes is one person and he's trying to validate the block. And the 10 nodes, stake into the, whoever put the stake, all the 10 nodes will lose their stake and sort of uh, lose the stake in the network. This is how, and nodes usually don't want that. You don't want to lose your property and transaction, everything now. So this is how generally a blockchain works and it defends against several attacks. These are few ones, and these were the few problems it was dealing with them and everything. And let's see what a wallet is. A wallet is something which allows users to manage their cryptocurrency holdings and perform transactions, store cryptographic keys, private key, public key. I just now told what they're used for. And okay, let's see how actually it works in real life. Let's make a transaction now. So I hope you guys made a MetaMask account. If you open your MetaMask account now, I hope you guys will do it with me. Just a little bit slow. Okay. Okay. This is how your MetaMask account is. As you can see, here we are in Shipole network. If you open to create a new account, it would be an this Ethereum mainnet. You just have to shift your network. You have to click this show test networks and convert to Shipole. What is this? This is a test network where you can see how transactions takes place in a blockchain, what they do and everything. Let's see. First, you start with zero. Nothing is there. So you have to go to a website known as process. You go to website faucets.chain.link. Go here and you copy your wallet address. If it is showing I already connected with my wallet address. You can see here it is showing. It will otherwise it would show connect wallet. You just connect with your wallet. It just a pop-up of MetaMask appears and you just connect with it. Let's see. Now we'll request 0.1 ETH. We don't want any test length token. We'll just go for and GitHub. You guys sign in with the GitHub. Let me just pause for a second. I'll just sign in GitHub and get back to you guys. Now that I have signed in with my GitHub, this is send request, and it will start sending zero point 0.1 test ETH to your account, waiting for confirmation. And it's transferred, yes. On this, you see, and here what you see is a transaction hash. This is a unique hash which you get every year. Transaction has a unique hash. This is a unique hash you get for every transaction. Click on it, you can see that it is showing indexing and success. Yes, the amount of ETH has been through it. And remember, this is not the actual ETH. This is testnet ETH in Chipolia. Yes, now the ETH has come to your ETH has come to you. Hmm. You have received ETH from this faucet. As you can see, this is from this account, from this address, from this wallet. This is a wallet addresses are represented, and this is to my address here. 0x69 here 066. This is my account, and if you click on my account, you can see essentially uh, what a transaction. This is what I meant by transparency. Uh, Essentially, you're not uh, connected to the identity, but people can see on the blockchain that okay, from this wallet, this address, transactions have been this from this is the block number, how much time ago did it go from this to this, how much value and everything. Essentially, if someone has your address, and which everybody will have, whoever runs the blockchain software have your addresses, they can essentially see what is going on. This is what I meant by transparency. You can see even if you just copy my address, even if you now type, if you go to shipolia.etherscan.io and you can type my address, you can see this transaction, and it is visible to everyone in the network and whoever interacts with this. So this is how you receive something. Now let's send something. And you just create an account. You can see you can create another account and another account is create, and we have two accounts now. And what I'm going to do is I'm going to send from my account to account two just to see what will happen. You'll see there is something called fee here. Okay, we'll see about it now. I'm sending 0.05 Sepola ETH, showing how much estimated charges and everything, estimated fee, getting pending. Now, yes, this transaction went through. As you can see, I sent only 0.05 ETH, right? Now it is less than, and I should have 0.05 ETH, but it is less than 0.05. So what happened is, and this guy who I sent to has 0.05 ETH. So let's go to my account. Refresh this. Now you can see that this is the transaction hash, the the money I just sent from this account to this account. I sent this much. What is it about? You can see status is success, and we are saying two block confirmations. What is this? We'll look into it and timestamp. from this to this. Value is this transaction fee which you pay to the miners who mine your block. And by now you should know that miners get rewards by two ways. One, he mines the block, and he either by mining, uh, getting the block reward, other by the transaction fee you pay, by the gas fee you pay. What is gas? Gas is this amount. Gas is something you pay to the miners. Transaction fee. This is the gas limit, 21,000. Gas fee, max is this, and we'll see what are burnt and everything at the end. So gas price is something you can see cross price offered to the block producer to purchase this amount of gas, and this is what how a transaction essentially goes. This is very easy, right? You don't know, you need not to go to a bank or anything. The this they didn't even ask me anything, any verification or anything. And essentially, this is a test network. This is not actually, as you can see, if I change my test net, you can see that it is still zero. Each folio has 0.05 ETH, and account one has that much, and account two has this much. And at the beginning of the session, I said something about private keys, right? And you may ask me now, where did this concept even come from? Where are my private keys? I didn't sign anything. Where are my public keys? I didn't sign anything here. And you just sent that it is taken care by the software. I'll show you my private key. Where is it? Private key. This is my private key. Yeah. This is essentially you don't show this to anyone, but as this is a test and I'm just showing this, generally this is not shown to anyone. This is very private. I cannot show this to everyone. And anyone who gets access to your private key gets access to your account and all the funds in your wallet. Not in your wallet, in this account. And you may know that while creating this account, you must have heard about something about secret phase, keep it safe and everything. The way if you did if you set up your wallet as the video I sent yesterday, in that they say that secret phrase is very important. Yes, what it does is where if you get the secret phrase is the combination of your account number and some other things, and secret phrase plus some other things and your account number, and you push it to some cryptographic function and it gives you a private key. With this you can get the control of the account, and with this in mind, uh, a public key is generated. With this private key, a public key is generated. This uses something called as elliptic curve digital signature algorithm. So with this private key, a public key is generated, and with this message, you just sign them. Everything is done by the software. You don't need to do anything. This is how essentially a transaction actually takes place on the surface level. We are not nodes, right? We don't need to maintain blocks and everything. We are just normal people want to make some transactions. So this is how normally a transaction works. So I've shown you how a transaction works in the blockchain, and that's yes. Now I've shown you how a transaction works and everything. Transaction is requested. A block that represents the transaction is created, and every node, a block is sent to every node. Nodes validate the transaction. Nodes receive a reward for proof of work. Block is added, and transaction is complete. And and what is gas fee? This is fee for executing the transaction and updating the state of blockchain. Gas fees, price into units of gas used, and gas price is the amount of that the user is willing to pay for each gas unit. And this is how essentially everything happens. So let me give you a recap, and let me give you a recap. So what is a blockchain? It is a decentralized, immutable trustless verification system. And first, some of the math born cryptography. How it works? It works by creating blocks of data that are linked in a chain-like structure, and it works by creating hashes like this. You get a hash from this and extend this idea to a block. And what does this hash do? What does this block do? It essentially takes block none's data and together passes through a hash function, produces a hash, and one more extra data is added into a block in a block to chain them together. A previous block's hash is even added, and after adding a previous block's hash, you mine them. You start mining them and to get the previous block, and this sort of links them together. As you can see, if you want to go to the previous block, I just see, okay, this is the previous hash of the block. You search for the block and go, okay, this is the block I've been looking for. Again, okay, again you have to go backward, search, and sort of go backward, and you can see every transaction that has ever happened. And as you can see, if you tamper with it, the one who holds the blockchain has the most power. So what do we do this? We distribute them to normal people, to all people, and the person who maintains a copy of the blockchain and essentially maintains the decentrality of the blockchain are called nodes. Nodes have a copy of the blockchain, and essentially what they do is they maintain the immutability and secure nature of the blockchain. They make up uh, what a blockchain is, how a blockchain is decentralized, and this is how general transactions go. And after that, I discussed this has a major flaw too, because what if say, you just hear what if a node hears as I said, nodes hear if you send a request, nodes hear the broadcasting message and they condense it to a block and mine them. What if someone is trying to act maliciously and tries to send fake a transaction like Rick is sending to Elsa. Essentially, Elsa is trying to fake a transaction that Rick has sent me $62 or something. How do we tackle this issue? Uh, and how do we tackle this? By using public and private keys. Uh, how do we know that? What are they? They are generated in pairs. A private key is something private. You keep it with you, and public key is something you publish to everyone so that nodes can check your transaction is valid or not. And they are generated through cryptographic algorithms. You take this private key, push it into a function, and get this public key. And and then what does this do? Is this you take a other cryptographic function, pass the message and private key, and you sign this message. And the function which you sign this are not SHA-256. Keep in mind that is a other cryptographic hashing algorithm. This is different. This uses another cryptographic algorithm. You essentially sign this, taking the message. Imagine it as a function. It takes message and the private key, signs this, and so you get a message signature. And to verify if it is yours, you send the message, send your public key and your signature, and nodes verify them. And it is impossible to get your public key, to get your private key with the help of your public key. You cannot backtrack them. And this is in a typical how a typical transaction looks in a blockchain. You send this money from this public address to other public address. This is your private key, which you do not show, sign, and the notes just verify them. That's all. This is how This is what a public and private keys are. We talked a little bit of consensus. What are consensus? It is a mechanism used to agree on the state of blockchain. And even though this has good implications, like it cannot still, there are some problems with it because somebody can gain influence over being majority and pretending to be more than just one, creating fake identities and being more than one. In the blockchain, as majority rules, they can try to be more than one. So what is that? It is stopping them. These are Sybil resistance mechanism. What they do is this mining is actually proof of work. What you're doing here. This essentially stops the guy who's trying to somehow manipulate the blockchain. How it is actually very computationally very expensive. Uh, for, Forget about running 2 or 3 nodes. Even one node is actually very computationally expensive. Computationally very expensive. You have to spend more and more with that. Even with a node, it is a bit difficult. If you try to run 2 or 3 nodes, you cannot. And officially, and you are not racing against just one or two. You are racing against the whole network who's trying to mine the block. You cannot compete with them. So if you want to compete with them, you have to create two or more, and you cannot do that in proof of work. But this is environmentally very, very damaging, as every node tries to find this block, uh, find this nuns, for solve this puzzle to get the block reward. And as this is very environmentally risky, we moved on to next Sybil resistance mechanism, which is proof of stake, where nodes lock up a certain amount of cryptocurrency or tokens as their stake in the network. If a node is trying to act maliciously, he will be shashed off it of his cryptocurrency, of his wealth. He will not. He will be the. He will be punished for it. He will be taken. Some amount of cryptocurrency is taken from his stack. That's how it works. We saw what our wallet is. What our wallets allow to manage your cryptocurrency holdings, perform transactions. Just know we performed a transaction in MetaMask. How it works. And you can see that there is a visibility too. Everyone can see your transaction and everything. Nobody can. Uh, Everyone, if you copy paste my address, yes, you can see my transaction. I just sent this and this. This even works even in the real network. This is just a test network. Everything exactly same. This is how you get practice to a network. And we saw what is gas fee. Miners not only earn from your block reward, they earn from your amount of gas you pay them. And if this actually came into picture because when there are several transactions being requested, you essentially put amount of gas fee such that your transaction goes in first. You can increase your gas fee, lessen your gas fee, but if you increase your gas fee, it is more likely that your transaction goes in first. The miner looks here's the transaction with this much amount of gas fee. Okay, it is more than the other what the other transaction is giving me. It takes the transaction which is more, takes it in the block first and mines it. After that, he looks after the okay, this guy is giving me less gas fee, I will look him after. Like that. This is the amount of fee you're willing to pay the miner so that your transaction goes in first, basically. And you see what our smart contracts are. And what are smart before introduction of smart contracts, it was purely just financial sort of service thing. As you can see, we were just talking about what are transactions, what do they do, how they do it, what are the different problems faced by it, and everything. After those were all solved, uh, after 2014 or 15, a group of people looked at this technology and took it even further, where you can code on the blockchain. And this is what uh, took this technology to a very new level and very made this technology very, very desirable. Because essentially, if you can code certain things, it just you can build very, very complex applications on top of this blockchain using this decentrality, immutability, and everything, la, share transparency and everything. So, smart contracts are known as building blocks of a blockchain-based applications. And every these are sort of digital agreements. Uh, what they what do they give rise to are what are known as unbreakable promises. So you see, any agreement where there was a trust assumption broken, smart contracts can be applied to and should be applied to, especially where big money runs and everything. With this technology, essentially we uh, move from brand-based world to a math-based world. What is brand-based? Brand-based is that you trust someone that okay, they keep their side of the agreement. But one who owns the agreement can just okay, we won't do that and just neglect the agreement terms of the condition. In smart contract, you can't do that. And since it is a map-based agreement, doing the right thing is infrastructure in a smart contracts. That is why this is very important section uh, where you just code on top of blockchain and everything. This is what is now very revolutionizing and everything. And the first blockchain to implement this uh, smart contracts thingy is Ethereum. So you'll see in a formal map what a smart contract is. It is a digital agreement that automatically enforces and executes itself. Computer program that runs on a blockchain. That is what a smart contract is. And once a smart contract is deployed, it cannot be modified or altered. Yes, because if it can be altered and modified, it compromises the immutability of a blockchain. So it cannot be altered. So you have to very careful before deploying a smart contract on the blockchain and provides transparency, security, and efficiency in transactions. So this is what a smart contract is. So let's see. Okay. Now what is Solidity? It is a programming language used for developing smart contracts that runs on blockchain platform like Ethereum. And it is highly influenced by Python, JavaScript. So let's see what is this programming language and how we can code upon it. We'll see what are the basic types in this. Let me and essentially to run this language, you need not anything. You don't need anything. You just have to go to Remix IDE. You click this. You go in there. This is where you can actually deploy your blockchain. I've written some code here. So this is how it looks. First, if you try to go in there, it will show some instructions how to go, what are these and everything. Just skip them. We'll come directly how to try to code in an AP, how to code in Solidity. Here, this is a browser. You need not to do anything. Just go to browser. So let's see. Let's see what are the basic types in a smart contract are. First, smart contract starts with license. Uh, you need not know what it is. Just know that if you don't put this line in the start of your smart contract, it just throws in some warning. So just put in there first. And then we start by uh, defining the version of Solidity you're using. And this is not actually 0.8.0. There are different versions here. As you can see, it is 0.8.26. But I'm using 0.8.26 because this hash, this something, this symbol is there now. This ensures that, okay, I'm using the latest version of block Solidity. And After defining your solidity type, you just start with contract. Essentially, this is, if you know Python, Java, or anything, this is essentially like a class, what you define. You start by putting this keyword contract here. Here, what is the name of the contract you're going to do? And this, and you open these brackets and you start in them. You start coding inside them. So we look what are the data types inside Solidity, basic data types. What it is a string, public. What how you define a data type is you first put the data type, then you give the visibility. What is visibility? We'll look into it just now in a second. And you give the variable and assign the variable to anything. Like, hello world. What is bull? Bull is a, you must have known it is a true or false data type. And unsigned integer 256, basically what it does, it gives an unsigned integer. It takes in only positive integers. Int, my int, it can take positive or negative. And address is another data structure. Sorry, it is another data type. And this is a keyword. Okay, we'll look into it afterwards. So now that you have written your smart contract, these are the basic data types. Now that you have written your smart contract, let's compile them. What you do is from here you create your file, essentially name them .sol. Sol ensures that okay, this is written in Solidity language, and you basically write these down. And then what you go to Solidity compiler and compile this, and it gives a blue check mark here saying that it has successfully compiled it. Now what you do is you deploy it on a blockchain. You deploy it on a blockchain. You see that I'm seeing here deploy, and it is showing me what contract are you deploying. Data types. This is the contract. It is in summer school file, and the file summer school folder. It is in the data types file. So you deploy this. See that you're getting a check mark. Ignore all the things before this. Just testing. You see now. You see that it has been verified and it has been executed successfully. Execution succeeded, and this is what it is. So you deploy it. You come below and see these deployed and unpinned contracts, deployed contracts, and it gives you what are these. So the visibility I was talking about before was public. What you do is this public thing uh, shows the visibility here. If I just take this out, if I suppose erase this, do not give public. What it does is it does not show. I'm taking Control S, compiling it, and deploying it. Here is the smart contract. If you don't give public, what happens is, see here, before I remove the public, you can see the boolean here. And call this and it shows true. Now, if I take out the visibility is you want to be public or internal to the smart contract. So what this do is it shows you can interact with it. It creates a getter function here in the deploy contracts tab, and essentially you click on it and you can see what value it has stored and everything. Here, if I remove the visibility, you just want it to restrict to the inside the smart contract. That's all. You don't want it to be public. So here the boolean gets removed. Here boolean is there. Here it gets removed. This is what visibility structure means. You type get address, it shows the current address, and get contract. So my address, my int, it shows. If you click on my int, since it is a public, it calls this thing and shows minus 255. My uint, it is 10, and text hello world. This is how you print them. Not technically print anything, but okay, this is how you do write a basic hello world in this Solidity program. Now that you have known what are these are the basic data types which you will be using very frequently moving forward. So please try to remember them. These are I'm pretty sure if you know C++ or Java, you would already know them. This would be very easy for you guys to remember. So we'll see what an array is. Arrays are essentially like since Solidity is a statically typed language, you have to define what data type you're putting in before you define an array. So same visibility, you give a visibility to it. We'll see what these functions are later, but we'll concentrate only on this. And you give a variable, you assign an array. Same like string array, apple, carrot, banana, public values, array 2D. Okay. Now we'll see, we'll just deploy it. We'll see what happens. We'll compile array.so. Go here, delete the previous contracts and deploy arrays on contract. Deploy it. Go to deploy tab and see. Now you see that uh, yes, this is yeah. Yes. As you can see now, array 2D. How can you access now with this getter functions? You can essentially access what are the elements inside an array. If you type in string array, what are there in string array? Apple, banana, carrot. So what you can do is if you type in 0, it will show apple. Basically, what it does is if you type in anything, it gives the uh, what are there in the index. Yeah, you can see that if I type 1, I'm asking it to uh, get the value what is in index 1 in that array. It will give me banana. If you type 2, it will give me carrot and everything. But if you type 3, here it says transaction has been reverted to infinite state. This should be payable and everything. You cannot call. Basically, this is an error. Think it of it as an error has occurred. You cannot call more than that. So that's how it works actually. And these are arrays. And in an array 2D, you essentially give two values. Let's say you want to access the number 4. What you do is, it is in 2D array, right? You type 1 uh, because this is 0, this is 1, and comma, I 0. If now you are in this array, first you're seeing this array, it is in index 1, 0, 1, and you see uh, in this array, you see that 4 is at 0, 2D, and check, you get 4. This is how you do get values in a 2D array. So these are what basic arrays do. We'll see what these are in a little bit. Now we'll see what how do you define a function in a Solidity program. These are basic types. So same, you start by creating contract and everything. The keyword is function. First you write function and you write function name, and you technically write what input it should take in. Here is prime, in this close bracket uint number, and we'll see what is pure means. We'll see in a little bit. So what it does is public pure returns, and you should essentially define what it function returns to here itself in the tab itself. So what it returns is a bool. So what have I written? A function to check if a number I have entered is prime or not. We'll deploy it. We'll see how it runs essentially. So you compile it first. Let's go to compiler, compile functions, and go to deploy tab and deploy. See that here it is prime checker is prime. So if you give a, so essentially type any number give 10. Obviously, it is not a prime, so it gives false. And if 13, it is a prime, it will give true. And how it works? Here I will explain how to write if conditions and for loops too. If number is less than or equal to 1, return false. The function returns false if the number is less than 1 because it is a special case as there are no prime numbers below 1. So for how do you write a for loop in solidities? This is the initialization. You first take an u int I. You have to define before defining a variable. You have to define what type the variable is. So you put u int I equals to 2. Start with 2. This is the initialization, and you check. This is the condition. If the number is less than I is less than the number, what is number? Number is the one you gave. What is the output? Sorry, input to the function, and it increases the value by 1 every time it goes. So if this loop is true, it goes inside and sees if number percentage 1. I'm sure you know what a percentage is. This means it gives, if you divide a number with another number, it, it gives the reminder. What this operation does, it gives the reminder of the number you're giving. It checks if the number is divisible by what number, I. This I goes from 2, 3, 4 until it reaches the number minus 1 because that's the condition we want. It checks till the before number checks before the number that we want to know if the number is prime or not. Divides, checks the remainder. If it is 0, yes, then returns false. No, it is not a prime. It is not. We'll go here, finish this loop, come here, and returns true. I know there is better logic to find what is a prime number or not, but this is what basically I could come up with, teach you guys. So this is how a function works, how if conditions work, how for loops work, initialization, the condition, and the argument, and what you want to do, and sort of go over and over. It increases. I'm sure I plus plus means you just increase the value by one. Yes, it gets divided false to. That's all. This is how you check a prime number. If it is a prime number using, and there is a visibility to functions too. As you see, this is a function I've called is prime, right? This I have assigned the function visibility to public because I want to check now. I want to enter something now. So the even functions have visibility too here. You just remember that you can give a function if it is public returns and everything. We'll see what pure is. We'll see in a minute. So let's go what a constructor is. So what is a constructor? It is a special type of function where it only executes only once in a at this you always put your constructor at the top of the before deploying your smart contract. This executes only once if you deploy the smart contract. This is everything else is the same. What you do is you put suppose string greeting and you assign a constructor that greeting what should be greeting be uh, and you get greeting after enter. Let's deploy it and see. We deploy it. First, what do you do is compile them. Control S. Go here. You can see and it is asking before the contract. You can see I cannot deploy it right now. Before I can just click deploy here for everything before. For constructor, I've given a condition that before the contract gets deployed, I have to take in some value. This is what constructor does. I cannot deploy unless, let's say, we give hello here, and I deploy it. Then the contract gets deployed here, and we'll see what I put hello. It gives me essentially what this function does is function get greeting. It gives me the greeting which I've entered here, and So here we are starting it with by string greeting, and it takes in greeting. We are just putting this underscore here to just to differentiate between state variables and local variables. You assign this greeting to the underscore greeting, and you might ask, what is this memory? Whenever you call string, you should tell, tell where it is stored, as this string is temporary during only during the function calls. You just mention it in the memory such that it is temporary. Since it stays only during the function call, you assign string memory here wherever in a function. When you call a function, when you call a string in a function, you just put memory here because you have to mention where the string has to be stored. So function get greeting public, you give the visibility as public so that you can, it creates a getter function. The returns string memory and return greeting. Whatever you have put before deploying the contract, it returns me that thing. I will just deploy it and get greet. Sorry, this is the contract of this get greeting and you get hi. So we'll see what a struct is. What a struct is something which lets you create your own data type. These are essentially, uh, as you can see, these are all the inbuilt data types like string, boolean, everything, address int. Here, what the struct does is it essentially makes you create your own data type. Okay. Uh, Before going into structs, we'll take a small break here uh, for filling out attendance. So we'll take a small break here, hoping that it's fine. And scan this QR code so that you can fill out your attendance. Fill the Google form and you will get the US formats. This thing, fill out your attendance. Okay. I hope you guys filled out your attendance. Okay. We'll start now. Okay. We'll continue. What a struct is. So this is how. So what a struct is. It essentially lets you create your own data type. And how do you create them? You use this keyword struct and any name of the data type, string, name, int, age. Hmm, like that. I'm trying to create a person data type, so called string name and int age, and I'm making it public. I'm creating a person. As you can see, data type first, public, and person is the object of the instance of this object I'm trying to create, of the data type trying to create. So first, I'm deploying a constructor, string memory name. As you can see, with if you're trying to take in a string or return a string, always put memory in it because you have to give where the string has to be stored. So string memory name, comma, uint underscore age. This is, I hope you guys know what is a state variable. Okay, we'll get into it in a little bit. So this is essentially state variable. What is a state variable? What it does is this state variable is prevalent among all the functions which you are going to write. But if you take in any function, explain it here as well. So this variable you can call it in any function. But if you define a variable inside the function, it is only to that function. It cannot be used outside that function. And these variables are written to the blockchain. You can use them in any function. This is what a state variable is. And what are local variables? Local variables are written inside the function, which cannot be accessed by another function. So you're writing a constructor before deploying the contract fully. You writing a constructor that okay, you should take name and age of the person by person data type, and you're writing a getter function to get the person name and age, return person name comma age. You have to sort of match these things. Person dot name. This is how you get the string thing, and person dot age is the uint data type. So we'll save this. We'll see how it executes. Go here, compile structs, delete this, and okay. Now it is asking before deploying. It is asking me name. We give my name 90, age 90. I'm deploying it. Here you can see the contract has been deployed. And you can see get person. It gives you string. Get person. Yes, it gives you the string first, and you want to what the age you have entered. And where is this person coming from? It's coming from this public, as you given it public, made it made its visibility public. If you enter this, it gives the same thing, basically the same thing. Both are the same. Just I'm writing a function to show how do you get variables. Or if this is not public, you use this string comma un. This is how the syntax is. If you write a custom data type, or struct essentially lets you create your own custom data type. So this is how you write anything to get custom data type. I'll see what are global variables. So these are okay. Well, let's see global variables. As you can see, these I've written outside any function. These are not any inside any function. So these are called state variables, which are stored on the blockchain and which can be used in any other functions preceding this everything. And if you write inside a function, suppose this uint I256i is there. This is a local variable which can be accessed only inside the function, only inside that particular function. You cannot access it to any other function. And here some global variables. Okay, now what are global variables? This is not same as Python. Global variables are accessible across blockchains. These are across variables which are across not blockchain, my bad, across smart contracts. Whatever smart contract you write, these are global variables. Like you can access them. This inside only this contract. This inside only this particular function. These this block dot timestamp, message dot sender, everything. These are accessible throughout smart contracts. These are like global to all smart contracts. These are just you can execute them in any smart contract. These are what are called global variables, message and block. And there are some other global types. And I decided to pick only these two as we'll be using them further in the future. Next session. Block and message. These are the global variables. What does message? The message is a global variable, and dot sender is its functionality. What does it do? It gives the address of the caller who's deploying this contract or who's calling this function. Since you're writing this function, it gives me the wallet address who's calling this function. And generally, smart contracts have this address data type. To address is a separate data type. It is not string or anything. Uh, this essentially gives me the wallet address inside. Let's deploy it and see. Saving it, filing them, delete the previous ones. Now deploy them. You can see that. Okay. Now what it does is if I click do something, see I've written what it returns. U256, U256 address. This can be in any order, right? This is not this. This should be linked to this. This should be linked to this. Those can be in any order. So U256. This gives me this. Since after click the function, U250. This gives me the timestamp of the block, and this gives me the address of on who called see. As you can see, my account is here is some 0x03c and everything. Here you can see my address here. This and this both are the same. Okay, let's see if I change my account and again click on this function. You can see this the address has changed, the timestamp has changed. This is what this essentially what does this message sender do? It it gives me returns the address who's calling the function. And if you write at top, okay, we'll see in the next one. So this is what message.sender does. Essentially gives the this thing. This is what num and text here. These where does this num and text come? Here from here. Num and text. These I gave them public visibility so that it creates a getter function and these two. So now we'll see what are modifiers. Okay. What are modifiers? Modifiers are this is a constructor. Okay, now you're deploying a constructor saying whoever deploys this contract is the owner. That's what it does. You usually write this in the constructor so that whoever deploys the contract is the message sender and you are assigning it to the owner variable. Fine. After that, what are modifiers? Modifiers are just some extra functionality which adds a extra condition to the function. What it does is, let's say I'm writing this is how you write a modifier the keyword, and you use name of the modifier like this, and you write require. This is the requirement which you want, extra condition to the function you want to add. Message, make sure that message.sender is equal to owner. This is what it does. Whoever is calling the function is owner. If it is not, it prints this message, not the contract owner. Otherwise it returns this string. So let's see. This is a restricted function. This is what a function wrote. Public only owner view. Okay, view is another modifier. This is an inbuilt modifier. This is a custom modifier, and this is a custom modifier. I'm trying to say, okay, check who's calling the function is a modifier, was the owner of the contract or not. So view is another inbuilt modifier, which essentially tells me that you can generally access the variables which are in the blockchain. That is what view does. Now returns string memory and return name. Let's see what it does. Compile it, delete. You can see owner. I gave address public owner. Whoever deployed who something. My address is visible here. Who deployed the contract? This account deployed the contract, and you can see the address of my and restrictor function is showing Karthik. That is what I want to return. When the owner clicks, it should show me this secret keyword Karthik. What if I'm other than the account who has deployed? Here you can see you can choose your accounts anywhere. So let's see. I'm different from a different account and sorry, not deploy. I'm from a different account. The owner is this guy still. It gives me okay. Owner is this guy. Let's say if I tap the okay, what happens is okay. Let me deploy this contract again a little bit. So okay, this guy deploys the contract. I'm the owner. As you can see, before the restricted function was accessible by this address. Now I'll change my address and take the restricted function. Now I cannot click the restricted function to see the uh, secret keyword. Why? Because it should throw me an error, not the contract owner. Here it is showing me the error. Okay, I'm not the contract owner. So you cannot access this restricted function. And if I go to my original account, this okay, hoping that okay, yes. If I go to my owner account, whoever deployed the contract, I can access the secret keyword Karthik. This is how a modifier works. It sets some restrictions and add conditions to the function. And you may ask, what is this keyword? This essentially what does this keyword do is it is a keyword. It tells the function to okay keep executing until the condition is true. It keeps executing until the uh, whatever is running in the function is true. Keep executing it. This is what the key function does. This keyword does. This underscore does in a modifier. This is how a modifier works. You basically add extra condition, your own condition to the function. Okay, now we have covered everything. Okay, now let's see what a let's see what a uh, this is actually a good contract. We'll see what this contract. Let me delete this. Okay, fine. Okay, what this contract is about is I'm trying to create a voting contract where there are two participants. I cannot add more than two participants. Strictly make sure that there are only two participants, and you can vote for the participants, and you can declare a winner by using a solidity. Okay. Declare the winner by writing a code. Write a code for it by voting. And let's see how this works. See, you first start by everything. So license, just add this. Otherwise, it throws random errors. And your solidity version, contract, and your contract name. Now you're creating a struct participant who are going to participate in the election, like who are going to be candidates to for the elections. getting a data type string name UN 256 oats. You are getting two variables. You are assigning two parameters to the data type participant names and oats, and you're creating two instances of the data type participant string name data type public visibility and participant one, whoever participant one is other thing. Now you're writing a constructor. Before deploying the contract, you want to the participants to be only two. You don't want to add a third one in between when the elections are going on. So what do? You write a constructor. Constructor is very similar to function, as I told before. You just write whatever variables you're going to take in inside the function. String memory name, comma, string memory name to whoever is going to participate in the election. This is before deploying the contract. Remember that. So participant, your data type is created of you essentially write name one and they you make sure that they start with zero votes so that there is no cheating and everything. Just make sure that they start with zero votes and name of the participants and everything. And you're writing a function. How do you vote for a participant? And you're making it public. Participants one dot vote plus plus vote plus plus it as you know, if you click this function, it increases participants one's vote by one time. If you click it one time, same for participant two. And how do? And then write a function to get the winner. The function get winner. This function did not take in anything value, any value. So left it empty. Public view returns. You make it public and returns string memory. What it does is if participant vote one dot votes are greater than participant two dot votes means participant one has secured more votes than participant two, you return participant one's dot name. And elif if participant two has gets more vote than participant one, you return participant two's name. Else both are tied. This is how a simple voting contract, how you write a simple voting contract in Solidity. I save this one, compile it. Okay, already compiled it. Fine. Now you can see I can give here names, any name. Let's say I'm giving somebody's name Karthik, comma Tushar. These are the two candidates. So they're going to participate in an election and people are going to vote. You deploy the contract, see the contract, and you can see there are buttons. You can vote for anyone. So I'm voting for Karthi. Some guy comes and votes for Tushar. Like that, it goes on and on. Let's say Karthi gets three votes and Tushar gets only one vote. Now you elections are finished and you call this get winner and you see that Karthik has got more votes. So Karthik is the winner. It returns. You go to participant one. It says Karthik. How many votes did he get? Three. Participant two, Tushar. He got only one vote. This is how you write a simple contract, simple voting contract using functions and everything I've taught before. These are essential small data types you have to know, how arrays, how functions are written. Practice them once. I think for the next session you need them. So practice them, go to Remix IDE, write different functions, try to get a hold on them. And this is how all these basics of Solidity. These are what constructor, what are everything. So now we'll just go through a formal. I just written them so that it will be easier for you guys to revise. Code that performs a specific task, function name, visibility, modifier, returns, and return type, what it is going to return. You add your code, you can use function parameters, execute operation, and everything. What does the constructor do? As I explained before, automatically executes only once. A new instance of smart contract is deployed, and this is how it is very similar to function, but may only difference is it gets executed only once. The start of we set initial values for state variables or perform. This is what we have done. What it does is in the voting contract, we get it again. So this is a state variable. You're cutting up your new data type and everything. This is state variable as this is not dependent under any function. So when you deploy, it starts with the initial zero votes zero. You cannot do anything since it is only deployed once. It starts with zero. This is what mean by stating initial values for state functions. Mean perform other setup tasks. And these are what auto modifier is. Acts extra behavior conditions to the function. Add conditions for behavior here. This is a general syntax and everything. Please better remember them. And if conditions are met, you can use this keyword said here before. Modify this keyword to continue executing the modified function to keep executing and because the conditions are met. Until the conditions are not met, you keep executing the modifier function. You can use return everything or struct as I explained before. Just it lets you create your own custom data type, define variables, different data types, and everything. And at the end, I would like to give a small this thing. You might be confused. Okay, how did you connect? At start, we started with blocks and what do we do, proof of work, hash function, everything, and then you suddenly jumped into smart contracts, saying that you could code upon it. How does this essentially work in nowadays world? This is a map, the general map into where in your Web2 world. What you do is you through the browser, you send a request, it goes to the central server and fulfills your request and everything. This is how essentially uh, we work in a Web3 world. What are Web3? Web3 is a world where you use blockchain technology to sort of make it decentralized, secure, and everything. Instead of one server here, one server, one database, there are several nodes here. And with the help of smart contracts, see, you send through a wallet, through a browser, you interact with the, that's what we done. We have interacted with the website front end, like how we have done a transaction in MetaMask. This is the front end. You interact with it. It goes through a bunch of nodes with the help of smart contracts. They execute the node, they do it, they do whatever the request asks them to do and everything. And essentially you get them fulfilled back. This is how in a Web3 world, this is the map of Web3, how Web3 world works. And we'll see what are the potential applications of blockchain are. It can be used in financial services, cryptocurrencies like Bitcoin and Ethereum are that they provide peer-to-peer transaction. Since since still this is an evolving technology, still many of them are coming on board into the space and trying to make more of it. Cross-border payments and remittance. Since cross-border payments, since things take time in traditional systems, it may take 1 week or 2 weeks just to uh, transact from here to another country. So, but essentially, what the banks are doing, they're just subtracting amounts from your bank and just adding it to the other account. This, if you use blockchain, it would be very fast. It doesn't depend where you are and everything. It just does instantly. And it is very transparent and secure. You can just see my address. You can whatever and all. You can just search up my address. You can see what and all transactions are made and everything. It's very transparent. It's out there, and it can be used in healthcare, securing secure sharing of patient records, enhance data privacy and security, streamlined billing and claiming process. Everything which requires transparency, decentrality, and everything. And voting systems ensures transparency and prevents electoral fraud, secure and immutable. Just like this is This one is simple. What we have wrote here in this voting contract. This is a very simple voting contract. You can add easily. You can find some mistakes. You can add certain conditions, make it more stronger and everything, so that you can ensure transparency. You can add more features as long as you have the ability to code. Now you can build any complex applications using it. It gives secure and immutable voting records, real estate, transparent property transactions, since it cannot be changed. Since blockchain nature is immutability, it reduces fraud through immutable records of ownership, simplifies transfer of property titles using smart contracts, and it protects digital content through timestamp records and ensures how you protect your IP, ensures rightful ownership and distribution of royalties and everything. So these are the basic applications. Still, it can. So these are very basic applications of blockchain and everything. You can not essentially blockchain. If you want to be specific, these are applications of smart contracts, where you can use these smart contracts to build these very applications and everything. It ensures everything, and these are the applications and everything. And I think with this we can end our session. Uh, I'm I'm hoping that you enjoyed the session and had fun during the session. So, and do practice solidity, because moving you will be learning them very effectively in the next session. So that is all from me. Thank you. Thank you very much for attending the session.